So, hello everyone, welcome to our presentation today about our Network Topology Explorer, which is a custom traceroute based internet topology analyzer we did under the computer networking class. I'm Deniz and I also have Muhammad with me. And in this section I'll be walking you through the networking engine behind the Internet Topology Explorer project. In general, our objective of this project is to analyze whether internet routing processes packets differently depending on the data they carry and how they impact performance as experienced by the endpoints. To study this, we implemented a custom traceroute-like tool that supports different port types we've seen in computer networking class, ICMP, UDP, and TCP, and it observes how the route and the hop delays change with each protocol. So first, there's a traceroute command and implementation that is given. We basically ping a source, and then after like the ping process, after like we give the code through the terminal line, we can then see the traffic. First we see any IPs and times, of course in milliseconds, latencies, the protocol type, in this case is ICMP, which has type and code and sometimes other flags. We can also specify the number of hops. Even if we don't specify, we can just not pass it in as a parameter, and then it will still be counted, and then it will still be computed, checked. And after that, we can go through like the general structure of the code. Firstly, we use many libraries, mostly SKP for the networking part, as SKP is like a really versatile tool for taking protocols, and we use a bunch of parsing, and we have a timeout because in computer networking sometimes even if we ping, we're not really sure if we're gonna get we'll be able to successfully communicate. So we have a alarm set and then a timeout class to manage the situations in which we need to raise an exception and make a timeout. And now we start a trace.
What you working on?
And while we get a TTL, and then we send time. And as you can see, there's different protocols for ICMP, for UDP, and TCP. We get the RTTs. We resolve the host name by socket if we can, and we print all these results, save all these results. And if there's an exception, getting the packages, or if there's any exception, basically going through all the do process, we try to resolve that, and we also check the hops. We don't want it to be more, we want it to be definitely a number that is positive, but no more than 255, as that would be too many hops. And at the end, the command line shows all this. Yeah.
And all the stuff that's shown on the command line is saved in a file. It's called trace output. Here's how it's represented there, and then this is the raw output which we are getting from the network. The code takes this raw output and let me show you here. It will take that and try to draw a graph out of that whole thing. I've added a few things in the graph. Let me show you in the graph. So this was the command which we run before, which Dennis just went over, and here's the graph produced by it. Here's the legend which shows us which protocol is used. Blue, it's ICMP. This is the information about our host machine. Whichever node I click on, I can get more details on that node. And if it all seems so messy because the screen size and there are many nodes, I can just move any of it around to make it more sensible for me to understand and have a clear idea of it in my brain. and there's like no issue of like you can like dragging it all the sides and stuff. Okay, let's try with UDP command. Okay, hold on a second. Okay, this is a UDP command. Would you go over the command?
Sure. We're targeting google.com with its like DNS name, which can be basically traced here. Our protocol will be UDP, and we're also defining hop numbers as 20.
Okay, so here is it. It's pretty much the same. It's just because we use a different protocol, so it's represented by a different color as per the lesson. And whichever node I click on, I can get more details on it. Let me go over the code again and tell like what multiple options can be added. Okay, so here's our makefile. We can add this the target, the protocol which we are using, the IP which we want to find, and the number of hops which we want our the explorer to explore. The readme file is also added. It goes over the features of it, and the how-to file tells you how to all the libraries and stuff which we already need for the code to run in Python. And one of the important things is it needs root access. We've added this word sudo for it, so if you're running it for the first time, it will ask you for your root password. I was running the terminal as an administrator, so it did not ask me. So that would be it. Hopefully you would have fun.
This has like something to do with like the behavior of what I like to add is like in general behavior of Scapy is that you need like root privileges in order to be able to basically ping. So that's like one of the libraries we worked. And something I forgot I'd like to add from like the code is like as each probe is sent, because as with P you can see we're like sending different probes. We're sending right now what we're saying is like we capture the raw responses and analyze the IP level behavior, like whether intermediate routers are responding or not, how long each hop is taking, whether the end destination responds for different packet types. We've been over like TCP, for example, whether it gets filtered, or ICMP, whether it gets delayed. And at the end, we can also see this like the whole topology with what Mohammed just mentioned in the visualizer.
So I think that will be it. Hopefully you have fun.